He's not?
You're not.
Oh, it must be his Kiwi client.
It's weird that it lets you send messages if you're not connected.
Yeah, no, like before I was refreshing it every time I, got disconnected from a network like that. So I started trusting it more, and I guess that's what I get for doing that. There. All right. Anyway, so the problem I found today, this one's on Kattis. So probably going to be a little bit more difficult, maybe. It's ranked easy on Kattis. But basically, I'll give you a rundown. So you don't have to read all that so much. They give you this input, and so it's saying it's 5 lines of input. Each of them contains 3 elements. And each of these lines is, you construct a tree with those inputs. So it's going to be a binary tree that's sorted. So all these inputs are going to produce or end up producing these 5 trees. And they want you to output the number of different shapes. So you can see these 2 are the same shape of tree, and these 3 are all different. So you have a total of 4 shapes. So the output should be 4. And this one, they don't give us the tree, but apparently it's 2. So I'm sure there's some, like magical way you can do this, but the idea I thought of immediately was like keeping a set of sequences, and each of the sequences would be like, when you're creating the tree, it would be like 0 because I didn't move it anywhere. It's just right there. -1, or actually it would be 0, then 7. So it'd be like 1 because you went right, and then 1 would be like -1. So your set of sequences, so set is unique. So you would have like 0, 1, -1. So like those are 3 numbers you have regardless. And then 0, -1, 1, and then 0, 1, 1, then 0, -1, -1. So it's like for each tree when you're creating it, like obviously how like it's easy to create the tree, but as you're creating it, you would keep track of the movements that you made. And then since this is all in a set, it's unique. So if you try to add this sequence twice, it's not gonna, it'll ignore that. So at the end, you can just output the length of this set. So I think that's my straightforward solution, but that's probably not the easiest. Any ideas?
271 and 314 would be your 8 sets though.
Oh, I also did that one wrong. 265. That would be 1 or 0, 1, -1. Right. But which one?
Because 271 would be 0, 1, -1, and 4 would be 3, -1, 1, or 0, -1.
0, 1, -1, 0. Crap, you're right.
I have an idea.
Yeah, I don't know what I was thinking about that then. I'm losing my mind.
So here's what I'm thinking.
Yeah.
So every time we make a tree, we have a pointer that just points to the root node, and then we just assign a variable for each node based on like how many of its 2 nodes are pointing to another node. So like if its left node is pointing and its right node, we'll assign like a value of 2. If only its left is like 1.
Yeah, so the number
right is 0.
Yeah.
I guess none is -1 for some reason. and then we just move along each node in the tree.
What about if you had,
And that could be our sets. We just append each variable together.
what if you had two, yeah. Yeah, what if you had that? Because see, then this one's gonna have one, this one's also gonna have one, but they're two different shapes.
Well,
You're right, I think you're right.
this root will have one node one right pointing
Yeah.
node. That should be, I don't know, something, some number, probably 0. This one will have a left one now, so that'll be 1. And then these two all have -1, so it'll just be, so it would be like 0, -1 for that, and
So is your
1,
number,
-1.
is your number just the number of, like,
It's just a random
Making
number that I
nodes or-
picked.
yeah, but is your number, alright, so you're saying you wouldn't necessarily, this isn't necessarily just the count for how many.
Yeah, this isn't like
Okay,
a count.
yeah.
It's just.
I was gonna say, I think your idea will work, but numbers may not be the best thing to use. So
Yeah.
But yeah, if you're using just unique things.
Yeah, it's just unique identifiers.
Okay.
Could you count the left and right points for each one? Recursively?
Yeah.
Like that's 3 lefts, 3 rights.
Yeah,
I mean, it's the same idea, but.
I mean, since we're dealing with trees, recursion is probably going to be the simplest thing to do in the end. But
I just don't know if there's a way that you can make it.
yeah,
Like, if you say you have 2 rights on the tree, is there a way that you can make 2 different shapes out of 2 rights?
so you're saying if you have, repeat that, if you have two different rights on the same tree, like this,
Yeah.
as opposed to, I mean, if you're counting just the leaves, like, I don't know, something like that. I don't know how you do that recursively. You'd need to apply this recursively too, though, wouldn't you? So looking at their examples, yeah. It's for use the letters for that. Say like if it has left, you do the left. If it has a right, you do right. If it has left and right, I guess if you want to keep it just a single character, you could do B both or in none, and then it's some weird acronym. So for each node, you check that. So on this one, it would be both. And then for one, you pick whatever traversal you wanted, I guess. For one, you do none, and then for seven.
You do it that way. You do
Huh?
a string, you have a string, and you have for each
Yeah.
layer, you have a letter.
So it's like it wouldn't even matter what traversal you use. It would just need, you would use the same traversal for each tree. So in this one, that's 3, 4. So you've got. I guess we should let's actually pick a traversal. Like in order as these. I mean, they're all the same algorithm. Do it in order, I guess. So this one would be that one would be also NVN, but then for you'd have wouldn't go left, so it would be right, none, yeah. And then that one would be right, left. Oh, right, left, none, yeah. Yeah, I think that's doable. How do you keep up with the string though if you're doing incursion? I guess you could just pass in the string. Yeah.
String equals string plus.
Right.
Doesn't matter.
Oh, that's even easier. Yeah. The only thing I hate with Kattis here is you can't. It's not like with Hacker Inc. You can't type the code in there and run it against their cases. Yeah. Okay. Actually. We want to do it in Python. Of course. Oh, whoops. Forgot I was opening the folder. Alright, actually do the shebang. So, first off, you need to create a tree in Python to do that. So, input, might as well just do this as a complete program. Who knows? Okay, let's see, so that'll be the set that we use to keep track of the strings.
So they each only have 3 nodes?
Huh? In this case, the second number on the first line tells you how many nodes they'll have. They'll all have the same amount of nodes, which makes sense. I mean, that means in your set that we're using, we're all gonna have like the same length strings. So tricky. We're about to use one of those traversals that I was telling you about the other day, and I picked in order traversal because I like it. It's nice. Hey. Then I'll make a thing up here just for convenience. pass it the number of things to do. Tree. Trying to think if you would. Hey, you don't even have to create the tree, do you? Hey, you would. Yeah. I was thinking if you could just figure, like, produce a string based off of, like if you're creating the string, like as I go through the input, like the elements there, I was wondering if you could do it just like that without even creating the tree. I don't know. Probably make more sense to create the tree than do the traversal and all, so, yeah. Yeah, especially for longer than 3 elements. Yeah, we'll just do this. So, creating the tree. Java. Oh man. I guess I should do this. Yeah. I don't know if it's gonna give us an empty list or not. Let's see. Nah. It'll always be at least one, so. Okay. So go through the rest of the elements, then check whether it needs to go left or right. I don't know, I just suddenly thought I was doing like tree creation wrong for a second. I might be, I don't know. If element is less than root value, then and then root. Yeah, no, I am doing creation wrong here, but it's something like that. I'm blanking right now. You want to do? You need a loop here. Yeah. You like. Oh no, yeah. I need to pass in a root here, don't I? Usually, if it's recursive.
You can do it before loop. You just need to say.
Well, if I'm doing it recursively, I need a way to terminate it. So.
No, recursively. You just need to say like if the element is less than the root value, then if root is none or array, I don't know.
Why is it so difficult? Yeah, yes. Alright. maybe let's write this up here.
Root dot left is none, and you need to assign it.
Oh, it's weird how syntax highlighting doesn't highlight that. Let's do this.
And you can assign it to left.
Otherwise,
Otherwise, you need to go root equals root dot left. It'll do it recursively.
yeah, that won't work. But
I like
Wow. All right, go for it.
There you go.
Oh yeah, are you
It's in
right?
Java, but
These are methods for your tree or just for your solution?
for the tree.
Yeah, thought so. You can do that. Class tree. That'd be the other way around actually.
Yeah, the semicolons are red and just like that.
Oh wait.
Like when you put them in a line. I don't know.
You're losing your mind, man. You're losing your mind, man.
Visual Studio, trying to tell you something. Visual Studio
Yeah. Oh, this is on Node. What am I doing? Yeah, I didn't have self in before either, so I'm clearly just not thinking straight right now. What is link right? Oh, you're just setting it to? Okay. Oh, yeah. That was dumb. I was just surprised to see a function for it, or method. Yeah. And then cool Python stuff. I can call mine underscore link, and then I can just call the link function on it, and that gives me it will give me the size, but
Slow.
huh?
Slow.
Let's see. Yeah.
Why are you going to the length?
No, this will call my link. This is the size method on here, but
I know what you
yeah.
did though.
I don't know why. Well, I just put it on here because you guys had it on here. All right, we'll need it. I mean, I was having fun using my Python thing there, but okay. Yeah, I just have to define every single special method like that. You know? There's a lot of them too. Some of them I've never even seen used. Anyway, so now for looping through the elements, then so now you just do root add. Yeah, that's convenient. That's really convenient. I guess since we have this in class, we can do the string output thing here too. So that'll just be an in order traversal. So see, I did learn something from Bush. I write my very ambiguous comments first. Yeah, I'll need a string. Well, I will, but it's just gonna be weird whenever I call get pattern from the main function, because I'll have to pass in like an empty string.
Yeah.
Oh wait, I can just do this. Yeah, default. There you go. So needs a node too. Yeah.
Because yourself is
Huh?
yourself is the node, isn't
Yeah, but if we're doing it recursive, we'll pass in like root left or root right. So in this will be root left, and then string. Then here we'll say. We also need a terminator. I'll do that in a second. That be right? No. Huh?
Oh, the root node.
It's it's an in order traversal. That's what Adam was saying, but I think so. We can try it. Yeah.
I don't know. Python thing, so it should work.
Yeah. Oh. Maybe that's right.
You don't want to return the value. You want to return the get pattern. So,
For in order traversal.
your string
What?
is the value you want to.
I mean, oh yeah. You're right. We're doing this thing. So
So you want to self.get pattern there. Because if it's
yeah. Well, I'm wondering how we're going to translate these movements into the letters we have LRBN, because this
You
is
say,
the
like, if left is none and right is not none, then it's right.
you mean right
Yeah,
here.
it's like
Yeah.
case. Can you do like a multi-case statement in Python? Like case of like left and right?
You might can. There is like I'm pretty sure there is like ternary stuff, but we can always just do this. If self dot left, self dot right, string plus equals b list. Yeah. We wouldn't even need that. Yeah. And is that the correct return though?
I think you need to do your if statements up top and then do your get
I
pattern.
think here it needs to be your return string. No, it doesn't. No. Yeah. All right. See. So create Yeah, my that function name is kind of bad. Create tree because I'm gonna do most of the work here. Or I guess I can do this. Yeah, there. Now, just gonna print patterns for now. That too. What it do? Oh, for one. Oh. You caught it right away. That's why you meant. It's like surprise, surprise. You can write any code in Python. Okay, is that right? 5, 3, 2, 1, 23. Yeah, I forgot to do self, probably. Where's it at? Line 23, you can get better. Yeah. Yeah. Okay. Food. Line 27. Yeah, see, that's what I was thinking about the recursive thing is you need to you still need the node argument.
Well, can't you say self.left.get pattern and then just drop the self.left?
That
Does that work?
maybe. Try on this. Has no attribute. Oh, you would have to check if I just want to get to the second thing. Yeah, that I should have expected that. Oh, no, I didn't even mean to have that line in there. Yeah. Oh, yeah. How about that? That's wrong. That is wrong. So it's not returning our string. So it keeps creating the string, but see, so here it needs, I think it does need to be.
Adding the left side anyway. So if you're self.left.get pattern, you're not doing anything with that, are you?
Yeah, but then eventually that's going on that. It's going to get to this part though.
Yeah,
Like it's adding to the string every time you call get pattern for each node. I think it was this return thing. I don't know. No, that was not it. It's so much cleaner, yeah. Hmm. Yeah. It's just the string part that's so weird. I'm gonna print string each time, just see what it gives us.
String's not a preserve.
No, str. Yeah. Some separator, I guess. Actually. So it just hits the root is the only one it's doing. It's doing both. Huh. That's strange. See, so left is not none. Hold on. I'm gonna do this. If not, no, I can't do that. You got it?
Yeah.
How'd you do your string part?
My what?
The part where you create the string, or did you do the same method? Like,
Essentially.
Cause I think that's our problem is the string's not getting made correctly. Hmm. Hmm? Oh. Yeah. Oops. So you do that, then in order tree. It should give us, just to make sure that we did end up creating the tree correctly. It's in order, so that is wrong. Wait, no, it's not. Never mind. I was thinking of pre-order for a second. Yeah, that. Okay, so we did create the tree correctly. Like. One. So the tree is getting created correctly. Let me think about how it's doing this. So if you've got 2, 1, 7, it's going to, and this is our string. Oh, the reason it's doing the blank lines. Anyway, so this is not none, so it doesn't return string. Left is not none, so it gets this pattern here. And in this case, it will go into the left. This is not none, so since left is none, it won't do that. But then it'll check self left and self right. No, it'll end up adding it in. And then it'll do right, but there's not a right, so it won't do that. It's done with that. And it goes back up here. That's where it hits the root section. In this case, it should put a B. And then it goes to right, since right but not none. And that's going to only dispute the root part, which should be from, which is what we want. I wonder if it's my if self dot left and if self dot right thing. I don't know. I need to like directly compare those. I shouldn't, but hmm.
If none of those that doesn't work, you just get 3 ends.
Yeah, you should be getting something. Alright, well, I'm saying it's adding it on though. We could take a cheap way out. Instead of using string in their recursive function, use a global variable. I'm gonna try that. Okay. So then for each time we create the tree, we would need to set string and then instead of patterns.add here, it'll just be that, and then okay, so maybe I think that's it. Maybe. Yeah, you don't have to do that.
You should have return. You shouldn't do that, because if it doesn't
That's
find
true.
anything, it just makes its own function.
Who knows at this point? That's right. Wait, no. It's backwards, but it maybe it'll still work. I don't know. Is it B and B? That doesn't make any sense.
Try with them, plug it up.
Yeah.
That's the right answer.
We had LB. What was the 4 that we had? It was NBN. That was the one that they're mistaking for B&B. Let's see. It was
That LLB should be RRN.
yeah. Then
I think it's calling from the bottom up. Like it's looking, it's like on like 159.
hold on. Hold on.
Or left button 9.
In create tree. Nah. Well, that should be right. I don't know. We can try submitting it because the number is still the same. It just has like some things transcribed. I don't know, like, or if you really cared about that, you could always fix these. Oh, hold on. Oh no, I'm stupid. No, it is completely correct. I did the wrong characters. Well, no, it was correct before, but now since I did the direct comparison, there is none. So I just have to take that out. Yeah, that's why. Because I effectively like inverted all of those. So now if I did yeah, that's it. It only took us 50 minutes.
This was the easiest problem that year.
Wrong
Yeah, it's Kattis, so yeah, it's,
Did you
there's
do your,
it's probably some edge cases or something. Huh?
that's what I was gonna say.
Yeah.
I don't know how many times I've submitted a problem.
Yeah.
Debug.
Yeah.
Printed in
And it hurts. It hurts you in contests. Let's see.
there. 20 minutes trying to figure out why it's not submitted.
Time limit was 7 seconds on that. Jeez, they must have some huge inputs. It's always like nerve wracking when you do that. Yeah, me and Anderson were actually having trouble getting the freaking tutorial problems working one day, like a couple months back. It was like stupid stuff. I don't know. He was having some issues where we literally had the exact same Python code, Python 3, both selected that, and mine was working and his wasn't. I think it was on a different problem up there, the top, the one that was accepted. Wrong answer. Knew it. Figured. And you can't tell on here, so.
Probably the other sample version.
Oops. Okay. Yeah, I probably should have done that before anyway. Two. Mm. No. What? That wouldn't happen though. It said the input was at least one, so I don't know. Why that? I don't think the algorithm is wrong though. Like I think that would work. Just wish we could see the sample input, like the input that they had on that one. You can't? What? Alright. Alright. If you find it. Wonder if this just has. This probably just has those two. Yeah, it only has those two. You get yours working, Jacob?
I got a wrong answer on one of the test cases.
The test data is like 200 some
Jesus. Wow.
That's for all of them.
Really? That's insane.
All the products.
Hmm.
This is part of Worlds last year. Or I guess it's
That was from this year. Yeah.
I think
Hmm.
for that much.
Just think of some really hard trees. You just had like just go. Could you do for that? 5, 3, 4.
Does it tell you a reference if it's the same as the, like when you're adding it? Like should you go left or right if it's the same? Because if it's one or the other, I know that you're doing left. So if they're wanting you to go right, that would screw up. Yeah, they want you to go right. Well, if B is smaller, insert it to the left. Otherwise, insert it to the right.
Say it again. Where are you?
Left bullet point.
Oh. Yeah. Okay, so it needs to be. Well, yeah, yeah, this accounts for that though, because it's just an else here. So this is if the value is less than n, yeah, which is if v is smaller, insert it into the left subtree. So that's this one. Otherwise, that would be greater than or equal to, or like if the value is greater than or equal to n, then it would do that. So
Well, if
I
it's
think it.
greater than, then you're adding it to the right. But if it's not greater than, so less than or equal, you're adding it to the left. It should be the other way around. So you should put equal sign after the.
After this one?
Yep. I think so.
Well, this is. Let me reword this. That's the same thing. They're saying if v is smaller than the root, insert it into the left subtree, which is what that is, and then otherwise insert it into the right. So otherwise would be if the value you're inserting is greater than or equal to the root. But if it's equal to, then it will insert it to the right too. Yeah. Oh, it was empty. Create tree.
I'm pretty sure there's a sequence of letters that you can write where it's an ambiguous shape. Like it could be two different shapes.
Can you think of one?
That's the problem. That's
I was trying to think of it in reverse from like a shape to that. But if you had this would be neither left, neither right. I have no clue. So let me think of a way to make that. I don't know. I mean, I feel like this is unique. You have to think of like it's like trying to think. Is there any tree that you could come up with the same output for in order for different traversals? Like,
Alright. Well, that one would be NLB or N.
oh well, yeah, I didn't. Yeah, I forgot the B. And so, yeah, you're right. N L B R. No. Neither. Right. So yeah, that's it. Cherokee, you're an expert on trees. I'm clearly not. I couldn't grow a flower if I wanted to.
I was like, what if you had a tree that was like and then you took that and you rotated it so that it was now
Yeah.
that's the
Okay.
same number of nodes, it's the same pattern.
What's
Yeah.
it's different shapes though, isn't it? Like
NBR.
it would consider that as two different shapes though. So I'll do the one on the right. That's
That's this one.
the one on the right is NBNBBRR. Yeah. It's like, but you would want it to consider those two different shapes.
Yeah.
Yeah. So that would be fine. I think. If you can come up with some numbers and test it. Like if you call this 6. That's a 1, 0, 2, and then some 0 to do 6, 4, 8. How many nodes are on each of those? 9, yeah. So, 6, 6, 3. Can't even read non-writing over there. Yeah. works for us. That's all that matters. Except it doesn't. Oh man. It's 7 o'clock though, but I don't know. I can't imagine a case where it would be ambiguous. I feel like that's gonna be unique for every different shape of tree.
We're not keeping track of what layer it's on in the tree.
Oh, alright, I see what you're saying. Yeah.
So I think there would be a case. I think
Yeah.
like
It's hard to think of one, but I see what you mean. Trying to think if you had.
I don't know, I can't think of one.
Yeah, except this is a traversal, though. I mean, since it's a traversal, it kind of does. It almost does keep track of the level. Like, it doesn't, but the level does affect like where each of these occurs. Because the NB Here, these are right, and I think I have stuff on it. This would be NBR. That would NBNLB. That's where you're gonna start. You keep going down, though. So it'd be NBNLB. Then it would be neither. Or both. Neither. Both. Neither. Right. That's it. Then on this one would be neither, both, neither, both, neither, both, neither, right, right. So yeah. So I'm wondering if all the letters are unique. So yeah, they're not. That has L, that doesn't. So yeah, it's not even the same letters.
And essentially it just breaks it down into that. Those are the only 4 possible. And there's no way you can arrange those together to get the same letter combination or in a different shape.
Like, thinking about it, it seems like there could possibly be some case, but then again, it would be really hard to figure out a case where you could have 2 different at the same output. You can just ask the internet if this traversal is unique. Probably won't know what I'm actually asking, but yeah. According to geeksforgeeks.org, in order and pre-order and stuff. Oh, no. It's saying both of them, though. If you have in order and pre-order.
Yeah, we're not doing in order, pre-order, we're doing neither.
Well, we're doing in order, but you would have to have both of them. So, I know we're out of time, but say we did write like pre-order, then I guess what we would do is get the string for in order and then the string for pre-order, and if they're the same, then you would add one, you would have, that would be one shape, but if they're different, then you would have two. Right. So really you could just get the string for in order and the string for pre-order and add both of them to the set, and the set will, it'll keep track of all the differences. Wait a second though. The code's so similar for these that
We're doing in order traversal, but our pattern is not in order because we're not getting the value.
well, it is, but these are, it's just we're using letters instead of that. So it's like if you did yeah, you're right. That was a dumb idea, really, because pre-order and in order are gonna be different almost every time. I don't know what they're meaning then there. Following combination can uniquely identify tree in order. Yeah, they're talking about completely replicating all of the data. I see what you mean. Who knows? I'm lost. At a loss. So we'll have to contact Ben. Get Ben to solve our problems. Yeah, I'll push this up there. What we've got. Anyway. Sorry, Cherokee. We let you down.